binary is not actually that complicated once you break it down. There are only so many different values the binary can be. So we can either have 1 or 0. So 1 or 0 can be used in binary because it's a base 2 number system. If we look at denary, it's a base 10 number system, but that means we have 10 possible digits. So you could have 0 all the way up to 9, actually 10 digits. But in binary, we've just got 2 digits, 1 or 0. Now, if you remember back to when you were learning maths, you had units along the top of your numbers that said units, tens, hundreds. So when we did this, and we put the number 7, 5, 6, so you've got 7 lots of 100, 5 lots of units, 5 lots of tens, and 6 lots of units, which made 756. The same kind of process happens now, but in binary, we do it with different number headings. So getting the headings right is really important. We start with 1, then we have 2, then we have 4, then we have 8. You notice they're doubling. 2 lots of 1, 2 lots of 2, 2 lots of 4. So the next number is going to be 16, 32, 64, and 128. And if we get those right, initially, everything becomes easy. So, if I'm trying to get this number 1, we have no lots of 128, no lots of 64, no lots of 32, no lots of 16, no lots of 8, no lots of 4, no lots of 2, and 1 lot of 1 equals 1. If I want to do the same but this time for 2, it is very, very similar. So 0, lots of 128, no lots of 64, no lots of 32, no lots of 16, no lots of 8, no lots of 4, 1 lot of 2, and no lots of 1 gives me the answer 2. If I want 3, I need to think about this because there's not a number 3 along the top. So how can I do this? Well, I can do it with no lots of 128, no lots of 64, no lots of 32, no lots of 16, no lots of 8, no lots of 4, 1 lot of 2, 1 lot of 1 gives me the number 3. So 1 lot of 2 plus 1 lot of 1 gives me number 3. Okay, so if I gave you the binary number 1001, the first way to work this out when we're converting that into denary is to put our numbers across the top. So we've got 1, 2, 4, and 8. So we've got 1 lot of 8, no lots of 4, no lots of 2, and 1 lot of 1. Well, let's have a look at this. 8 plus 1 equals 9. Pretty happy with that. If I was trying to do it the other way round, and let's, for example, say I'm trying to do the number 5, well, if I'm trying to do the number 5, what am I going to do? 1, 2, 4, and 8. And you notice I'm not doing the whole range because I know I've got enough numbers there to work it out, because I'm not working like a big number out, I'm working in small numbers. If you were trying to do a larger number, like 128, you'd use all your numbers. But we're just doing small numbers at the moment, so I'm just using half of what I've got. In truth, 9 should be represented with more zeros, but we're trying to work out number 5. So how many 8s in number 5? Well, there are none. How many 4s in number 5? Well, there's 1. How many 2s in number 5? Well, the thing is, we're not looking for number 5 anymore, because we've just taken 4 away, so we're looking for how many 2s in 1? Well, that's going to be 0, and then we just need 1. Add that together, 4 plus 1, 5. Give us our number 5. Now, we can do lots of really clever things with binary, but this is just that first initial steps into binary. So remember, you can only have 0 and 1. We've got our numbers along the top, which double as they go, 1, 2, 4, 8, 16. Always draw those out to start off with, and make sure you can work in both ways. It does also help to sometimes put the grids in, so you don't get confused when you're looking down through the numbers.